I got a full screen. So a little lecture about quadratics, talking about them a little bit, and also some practice finding roots. I'm kind of of the mindset that quadratics forms the basis of most of the high school study of algebra, all the way up through calculus. Rectangles are very important. Quadratics are rectangles, just quad meaning four in Latin, and rectangles have four sides. And so much of what we do is based upon rectangular or rectilinear relationships. So let's get at it. It's got to be something for an early study. If you're just beginning your study in algebra, it's an extremely important topic, and you got to get good at it because the quadratic relationships come into play all over the place. All right, so let's see. I think I'm over here. Start here. I put a few things on the board to hopefully push things along here, so I'm not rambling quite so much. But so ax squared plus bx plus c is the combination of terms that forms our study, and they are rectangular in nature, and we can change those rectangular relationships into squares plus a constant. We'll do that in a little while. And there are three types of quadratic equations when we solve for equals 0. There's type A, I like to call type A the missing the linear term, type B missing the constant term, and type C all three terms. And how we approach the solving of each, my rule is what's the simplest, easiest way, and that's what we'll try to do. Okay, so solving equations, roots are x-intercepts. X-intercepts obviously occur on the x-axis, and another name for the x-axis is y equals 0. And so when you have a graph, then values are above the x-axis, the y values are positive, below are negative, and in between are 0. And 0 is an extremely important number in math. It's critical to find zeros and use zeros. It's a critical skill. So let's take a look at type A, which is one of the easier to solve. A little bit of a lecture. There's three types of quadratics. There's the type that intersect the x-axis. There's one where the vertex is on the x-axis. And then there's the type where the graph actually doesn't intersect the x-axis, which is y equals 0. I know in the textbooks we talk about imaginary axis coming out from the wall. It's a third axis. Honestly, I think you should be thinking about the quadratic turning in the other direction. And what gives us a turn, a sign change, I squared does. And it turns out that whatever these x values are, we call them imaginary roots, but they would be the same distance as if you were, let's say, going to a height of 10, and you were at a height of 5, or let's call it a height of 5 because I've already given some symmetry. So let's say that y value is 5. Well, you need to go up 5 units, and you'd have to find that x, and whatever that x is, it's the same magnitude, but just be imagining it going in the other direction, down 5, to hit y equals 0. Okay, I said that very quickly and a little awkwardly, but I think it needed to be stated. So 5x squared is a product, by the way. 5x squared is a product. It's 5 times x times x. And what makes that product equal 0? 0. All right, and that is the smallest square that you can get. You cannot get anything out of squaring smaller than 0, unless you put an imaginary in there. And we're dealing with your Cartesian coordinate system, so we're not going to find a real number that, although a lot of people think imaginaries are real too, could be a bad number. All right, so 5x squared minus 7, real simple. We've got three operations: subtraction, multiplication, and squaring. And so we'll do them in reverse order. So we're going to add 7 right to that side. We're going to divide by 5. I'll erase the plus. We know it's there. And we'll take a square root with a plus minus. Why plus minus? Because there's usually a positive side and a negative side to your answers. So two answers to quadratics. You either get two real numbers or what we call a double root, which happens when your parabola is, the vertex is on the x-axis, something like x minus 5 squared would give us a graph that looks like that. And we would call the number 5 a double root. But otherwise, you can see that we need a positive and a negative in each of these situations. And it takes students a long time to remember to write plus minus in front of even roots. Odd roots, you don't worry about plus minus. When you have x cubed, there's only one intersection. Sometimes they're positive, sometimes they're negative, but you only get one answer when you take the cube root of a number. So 5x squared equals 0. We just talked about that situation. That's a product. What makes it 0, 0? So x equals 0. That's the only time you get one answer is on a double root. And 5x squared plus 7. So we move the 7 over, so minus 7 divided by 5, the inverse is squaring plus minus square root. And we move the minus outside, call it I. We might as well show you how that works. 5 plus minus square root of 7/5 I. And let's square it. What happens when we square this? The plus minus becomes positive. When you square a square root, that's an inverse operation. And when you square the letter I, you get I squared. So what happens now? I squared makes 7/5 negative. It's a sign change. And we can see the 5's cancel and minus 7 plus 7 is 0. All right, so that's just mechanics. And there's a lot more we can study here, but let's keep moving right along because the topic is the simplest and easiest way to solve quadratics. All right, and your test coming up later in the week, I'm going to give you, I think, problems 11 through 16. Okay, so you got a bunch of quadratics to solve, and I hope you're able to look at it and go, oh, that's a type B. And let's solve type B. All right, then we'll solve the general one here in a second. I should have done the general one over there. So let's do that right now. AX squared plus C equals 0. Okay, so this is going to be type B. All right, but this is type A. So what does X equal? Plus minus the square root of minus C over A. And we don't know if that's real or imaginary because we don't know if C is positive or negative. And we honestly don't know if A is positive or negative, but it's going to be some combination of that. All right, so what is AX squared plus BX? Well, started this conversation about rectangles. It's really X times AX plus B. Right? That's a rectangle, four-sided figure. And if the area is 0, right, because this is producing area, I'm talking about the evolution of the study now, then to get no area, I see area here right now, I either have to get rid of the width or get rid of the height. So one of those dimensions has to collapse. So what makes this become 0? Think X equals 0. And what makes AX plus B equals? What makes AX plus B equals 0? Sure looks like X is minus B over A. Oh, so one of my roots, or any constant, honestly, is 0, and the other one is minus B over A. And inquiring minds might ask, well, what's right in between? Because that sure seems like the most important point of that quadratic. Well, it's the average of the roots. The average of 0 plus minus B over A divided by 2. And lo and behold, that's another way to think about the most important X value in a quadratic, minus B over 2A. In fact, the average of the roots holds for linear, quadratic, cubic, quartic. Go up as far as you want. Minus B over NA will get rid of the next term in the progression of highest degree to lowest, which means you can write any function in graphing form. Whether it's useful or not, that's another matter. All right, so AX squared plus BX, 0 or minus B over A. Well, here's 7x squared minus 2x. And I don't have an eraser. Yes, I do. Bear with me for 10 seconds. Okay, coming right back. So I like to do these the same way each and every time. I don't worry about the greatest common factor. I just take an X out. And that gives me x times 7x minus 2 equals 0. And I can see that this every single time is going to be one of my answers. And then I got to figure out what makes it 0 here. It's 2/7. All right, so therefore I've got my two answers very quickly. Let's try another one. 5x squared plus 20x. Okay, I'll just take an x out. I know 5x is the common factor, but that just leaves 5x plus 20. I don't have to think at all. Okay, one of my answers is 0, and the other one is minus 20 over 5, or I hope you can see negative. We could be talking more about this, but that's enough for now. We're just trying to get to the fact that, you know, a lot of times on the test that you were taking, this is what you'd show me on your answer key. When I said solve 5x squared plus 20x equals 0, you would generally get factored form of some type, whether it was 5x, pull the 5 out, either or. I mean, that's the same thing. You'd leave it like that. Equations are answers. I want to know what numbers I can plug in here. Remember, x is just a portal, means something. I want you to give me something that works here. And I'm suggesting that 0 does. Now you pause the video on this, slow me down. 0 plus 0 is 0. And I think we said minus 4 works. 16, 80, minus 80, 0. Yes, minus 4 works. So later in the video, I'm going to give you type A, type B, and we're going to do type C over here now. And I'm not going to tell you which it is, and give you a little practice on identifying and saying, oh, what's the quickest, easiest way to do this? Well, unfortunately, ax squared plus bx plus c, you got to get some experience, right? If you see type A, I hope you know what to do. If you see type B, I hope you know what to do. Type C, well, that's a little more challenging. First and foremost, if we can write it as a product, we're in great shape. All right, what's the one as a product? Well, I'll get to it in a minute. I've already got some stuff here. All right, but let's say we have a rectangle that's 20. Okay, products I'll take care of in a second. The other method is what we call completing the square, which is really a fancy way of saying put it in graphing form. Okay, and completing the square. Why do we complete the square? Because if you're gonna do the inverse of squaring, you need to take the square root of a square. You can't take the square root if it isn't a square. A square root is the side of a square. So here's a rectangle that's got 20 for area. Well, I can't tell you what the sides are. Every single one of these products gives me 20. 2 times 10 minus 2 times minus 10. 4 times 5. 3 times 20 over 3. I could do this forever. Smiley face times 20 over smiley face. All right, so there's really no knowledge about the dimensions. But as soon as I say 0, yeah, length times width equals 0. We just talked about it. I'm either getting rid of the width dimension or the height dimension. I'm either getting rid of length or width. I'm getting rid of one of the dimensions. Okay, so if my dimensions were 2x minus 7 times x plus 5, and it's set to 0, I can answer this question. One of my dimensions, if x became 7/2, it's gone. The other dimension is gone if I make my x negative 5. That's the skill you got to develop in order to go up the ladder in this discipline. Okay, so I'm really talking to first-year algebra students. All right, now, second ago I said, well, how about if I change this into a square? Because then I can use type A as a method of solution, inverse operations. So here's 20 units. Let's give some numbers here. 2 times 10. Okay, how can I turn that into a square? Well, I think the longer side has to get shorter, and the shorter side has to get longer, and those sides, they have to even off. All right, so I think I'm messing with 2 plus 8. This is 8 units longer than that. So how do I cut that in half? How do I make it even? I cut it in half. All right, if I cut it in half, then I got a 4 by 4, don't I? Or 2 plus, I make this one 4 units, and I take those 4 and I tack it on here. So I guess I have a 6 by 6. And that gives me 36 units. Now, how do I make 36 units into 20 units? I got to subtract 16. All right, so now let's actually give this some algebraic notation. So let's say I have x, which I'm going to say is equal to 2, and x plus 8, right? 2 plus 8 is 10. Remember, it was 210. All right. So how do I make that into a square? Well, I think I got a better drawing here. X and x plus 2, plus 8, sorry. Okay, which becomes x squared plus 8x, depending upon the length of x, that's going to be my area statement. And what I'm suggesting is you shorten the longer side, even it off, and if you do, you got an x plus 4 times an x plus 4. And if I square that, I get x squared plus 8x plus 16. This doesn't have the 16, so I get rid of the 16. So what did I just do? I said that I can take x squared plus 8x, and I can x, if it's positive, I'll keep it positive, I'll cut that in half, I'll square that, and whatever I square, I get rid of. That's completing the square where the coefficient of a is 1. And that's what we're going to, do more than, we'll do a bunch of those to get started. And then when we have coefficients other than 1, we're going to use a simpler method. We're going to do minus b over 2a. And we've been working with putting quadratics in graphing form, and you're having some success with that. And once you're in graphing form, which is ax minus h squared plus k, setting that to 0 is a piece of cake. Addition of k, subtraction of k, multiplication by a, division by a. Squaring, plus, minus, square rooting, and then negative h, positive h. Type A process, inverse operation. So we've got factoring, hopefully writing products, setting them to 0. That's one method of getting an answer. Putting it in graphing form or completing the square is another. And of course, this process, if I put minus b over 2a in here, I get plus b over 2a. And making that into a formula, which is the quadratic formula, which I think I've done somewhere in a different video. Right? That's how we get x values for problems that we can't factor easily. We get stuck. How do you know if you can factor something easily or not? The discriminant is what that's called. And if that's a perfect square, like the square root of 9, then you could have factored it. If it's something like the square root of 11, then you couldn't have. And you're either going to do the quadratic formula, or if it's easy to put it into graphing form, put it into graphing form. I'm a big fan of the graphing form, right? I think a lot of them, you can say, okay, if a is equal to 2, and you've got a 4, 7, right? When is that going to hit 0? If you look at this answer, 4 plus or minus the square root of 7 abs imaginary, all the numbers are going to be showing up there. And so keep an eye out for that as we put these in graphing form and solve. All right, so let's have a little go at it, and I'll give you a couple of quadratics that are type C. I see over there, I put a couple in. X squared minus 4x plus, let's do minus 21 equals 0. Okay, so I hope you're always pausing the video. I should have said that at the start, but with the problems we do now, pause, and I just keep going. Well, I can see this is a product. What numbers multiply out to be 21 or 4 apart? A 7 and a 3. The negative wins out, so that's the negative and that's the positive, and I can see my answers. X equals 7 and x equals negative 3. Use either one of those numbers in the equation, and you're going to get a 0. Now, this was a cup shape up. I know that I'm on the decreasing side. 0 gets me negative 21. Okay, and I know I'm going down at 4 to 1 actually at that instant. Right, so I do know that if I have some answers here, and I have 2, real or imaginary, they're both going to be what? They're both going to be, where was I? Minus 21 is way down somewhere, right? And so minus, so if I put a 0 in, I'm at minus 21, which is actually the y-axis. So I lost my train of thought for a minute. So I know one of my answers is negative, one of them is positive, just from looking at this, and I know my negative is smaller in magnitude. It's just a quick check that I didn't make a careless error. Just putting it in your head, starting the conversation. So let me give you another type of quadratic. How about x squared plus 10x minus 3? All right, so cup shape up. Y-axis is on the increasing side, so we just put that there. And I know that gives me 0, gives me -3. So yeah, this is going to have one positive root that's pretty small. It's going to have a negative that's bigger in magnitude. And if I want to find them, I'm not going to be able to write this as a product. Coefficient of 1, there aren't two numbers that multiply out to be -3. And there aren't two numbers that add up to 10. That both add up to 10 and multiply out to -3. I can only work with 1 and 3. That's not getting me 10, so I'm stuck. What do? Do I want the quadratic formula? I wouldn't do the quadratic formula here. It's too easy to write that as a square. So that's x plus 5. Let me change this to -10, just because I did positive the last time. This also can't be written as it's going to change my look. Now I can't do that because I already talked about this. All right, so x plus 5 squared minus 25. I just wanted to point out that it doesn't matter if this is plus or minus, right? It generates 25 units that I don't see up here, so I got to take it away. In this case, it's positive. Right? And I still have -3 equals 0. Piece of cake. -28 becomes +28. Multiplication by 1 becomes division by 1. I obviously don't have to show that. And squaring becomes plus minus square rooting. And +5 on this side becomes -5 on that side. And so, yeah, I suppose we practicing the square root of 28. So 2 root 7. All right, root 7 is less than root 9. Root 9 is 3 units. So -5 minus something near -6. So -5 this one would be near -11 right there as an x value. And -5 plus 6 is a small positive. All right, just as a quick check. Okay, so now I won't tell you what I'm going to give you for practice. And let's see if you can. I'll just make something up. So 3x squared plus 4x minus 5 equals 0. Now you can pause the video, you decide what you want to do. I'm looking at this and I'm like, you know what? Do I want to see if it's factorable? 15, 3, and 5. I don't think it is. So I would just go to quadratic formula, but to make sure that that's what I want to do, because I'm not going to put this in graphic form with fractions. Too much messiness. So I'm going to immediately do b squared minus 4ac, 16 minus 4 times parentheses. I always do that, so I don't make a sign change error. 3, -5. A lot of people make sign error there. So that's 12 times 5 is 76. So I've got the square root of 76, and yes, I could not have factored this. That is not a friendly number, like the square root of 64 or the square root of 81. So I'm basically done here. Minus b, where am I? Minus b. So -4 plus minus the square root of that, all over 2 times a, 6. There's my answers. I could do some work with that if I want in terms of, reducing it, taking out a factor of 2 perhaps. But bottom line is, I know what I'm trying to accomplish here, and I hope I did it the easiest way. All right. What else do we have? We have just some numbers coming at you. How about 4x squared plus 7x? You pause the video and go ahead and do it. All right. What am I seeing? I'm seeing x times 4x plus 7 equals 0. I'm seeing 2 answers. One is 0, and the other is -7. All right. What else do I see here? Well, I can see it goes through the origin, right? Because plus 0 equals 0. So plus 0 equals 0. I know I'm going up at that instant at 7 to 1. We talked about that in class and how I know that. So I can see one of my answers is going to be positive, and the other sure looks like it's going to be negative. Oh, yeah. One of my answers I meant to say goes through the origin, so 0. Positive slope. Okay, so 0, -7/4. All right. Now let's try another one. See, I wrote some stuff up. 2x squared plus 5x minus 12 equals 0. Okay, my brain is still going to see if I can write that as a product. So I'm going to look at factors of 12 that get doubled and then add up to +5 with the other factors. So 1 and 12, I don't see that. 2 and 6, 2 and 6, no, I don't see that. 3 and 4, 6 and 4, no. 4 and 3, I think 4 and 3 works. All right, so I would definitely factor this, but to check it out, let's do b squared minus 4ac. All right, and so b squared 25 minus 4 times a is 2, c is minus 12. Okay, so 8, 96 and 25, 121, yes, plus minus the square root. That's nice. So it could have been factored. And what my brain said was, I made this one the 8. I made this one the 3. So that's 8 and 3, and I want positive, positive, negative. So it looks to me like one answer is 3/2, and the other is -4. Let's look at this from a graphical standpoint. I've been giving you only cup shape up. I put a 0 in, I get -12. I know that. The question is, which side is it on? Do you know now just from this practice? It's on the increasing side. You follow from left to right. So I'm on the increasing side. 0 gets me -12. So where is y equals 0? Y equals 0 is somewhere up here. I have a small positive and a bigger negative. A small positive and a bigger negative in terms of magnitude. Seems okay to me. All right, so you have choices. And there are other choices too, but they get a little more complicated as in knowing the rates of change of each term and the interplay of those. You could figure it out that way. Okay, but basically, type A, inverse operations. One more time, type A. 5x squared plus 9 equals 0. X is equal to plus minus the square root of 9/5 imaginary. You do it out, that's what you should get. Factoring, type B, type A, type B. 5x squared plus 9x equals 0. X times 5x plus 9 equals 0, recognizing that this intersects at a height of 0 when x is 0 and when x is -9/5. Right? Type C. So let's see, what do we got for type C? Let's go. 5x squared plus 9x minus 4 equals 0. Okay, I know that has 2 real roots. How do I know that? Because if I put a 0 in, I'm at -4, and I know that it's cup shape up. So I've got one answer that's small positive, smaller positive than its negative counterpart. Is it factorable? 4 times 5 is 20. 20 and 1 doesn't get me 9. 1 times 5 is 5. 5 and 4, yeah, that can get me 9, but I'm not going to be able to get a negative out of it. They both have to be positive. 2 times 5 is 10 and 2. 10 and 2 doesn't get me 9. So I guess b squared minus 4ac is not going to be a perfect square. So b squared, 81 minus 4, ac, I got to do it quick. 5, -4. 80 and 81, 162. And that's what I think I'm getting. Plus minus b over 2a. Okay, now what's the square root of 162? Well, I know the square root of 144 is 12. And I know the square root of 169, I believe it's 13. So I'm between 12 and 13. Minus 9 plus 12 is +3. That's a small positive number. Remember what we said, -4 going up. That's probably this one. And the negative, Oh, yeah, that's gonna be over here further to the left. So it's off-centered left. Of course, minus b over 2a minus 9/10 gives us that feel as well. Okay, so what do we have here? I hope I didn't make any mistakes because I'm trying to do this fairly quickly. Now, if you had a quadratic in graphic form, the questions are real or imaginary roots? Can you just write them? They're real because I'm cup shaped up and I have a negative intercept. So x is equal to real square root of 7/2 plus minus 3. Right? Get enough practice, you don't have to work. But you got to really give it some thought. And so what's on every single test I've written since probably 2000? Effortless effort. Takes effort. Okay, so if you put the time in and keep thinking about it, you won't have to work so hard. Because you're going to be doing a lot of solving quadratics in your high school career. And if you continue up the ladder, you're going to be facing a lot of quadratics. All right, so hopefully that touches upon some subjects that are important to think about.